Hi, this is Andrew from XPS. Today we'll be doing the Clampset maintenance on an Okuma MB5000 horizontal machining center. We'll be doing this at NJet Aero in Sullivan, Missouri. The spindle in this machine is a HSK63A Black Edition. If you have a larger Black Edition clamp set, such as a A80 B100 or a A100 B125, the process will be exactly the same. We aren't having any issues with this particular spindle, but it's recommended to clean the clamp sets regularly for preventative maintenance to reduce spindle downtime. Neglecting this maintenance will usually result in tool clamping issues, low drawbar pressure, and other drawbar faults. If you're experiencing these issues, your problems could be solved simply by cleaning your HSK clamp set. This task is usually avoided by most people because it's overwhelming. But with our patented tools, specially designed for the OTT Jakob HSK clamp set, it will allow anyone from a maintenance tech to a mom and pop shop to accomplish this task with little to no experience. This process will literally take no longer than 15 minutes. It shouldn't be difficult for you to do. Follow these steps and keep your shop running efficiently. I'll add timestamps below so you can jump around in the video and reference wherever you need to. Also, if you're not sure what OTT Jakob clamp set your machine has, please refer to the machine manufacturer or visit our website at xpsmn.com and access our question and answers page. And if you still have additional questions, feel free to reach out. We'd love to help. The first step of the process is going to be verifying and checking the EM dimension on your HSK clamp set or on the front of the face of the spindle. We're going to be using our patented tool. It's designed to check the EM dimension and help you adjust it. So what you do is you'll take the tool and you'll magnetize it to the front of the spindle cone. So let's do that. With the EM tool magnetized to the front of the spindle, we're going to activate the drawbar and verify the EM dimension that's set before we remove it. The reason we want to check the EM dimension is sometimes some people that we've ran into with customers, they have a different dimension than what OTT has said, and we recommend that you want to put the EM dimension back to exactly where your machine was running perfectly fine. But obviously, we're going to want to go with the EM dimension from OTT. So let's activate the drawbar. So the Okuma is set at 416, about 417. So we'll use that as a reference to know that's where we need to go back to. And just do it one more time. 416. Now that we've verified the EM dimension on the Okuma spindle, it's set at about 416 or 417, we're ready to take a flat 24mm wrench, hold on to the spindle cone, and loosen the set screw deep inside the spindle cone to start removing the HSK clamp set. So let's do that. We'll be using a 24mm flat end wrench, and we're going to disengage the drawbar. So that's engaged. We want to disengage it. We're going to put the 24mm wrench on the wrench flats of the spindle cone and insert a 5mm hex drive and loosen it counterclockwise. Just like that. All you got to do is get it just a little bit loose. You should be able to take the spindle cone and turn it counterclockwise to remove it from the drawbar. And you'll get this. This is your spindle cone. Once the spindle cone is removed, now we're going to take the gripper segments and remove those from the cartridge of the spindle. To make this work really well, you depress one of the fingers and then the other ones come right out. You take one out at a time. There's one, there'll be 7 fingers. So OTT calls these the gripper segments. There's 7 of them. So now let's remove those. Now you need to get the spring-loaded spacer out of the spindle cartridge. We recommend using a long needle nose pliers. And you're just going to reach in there and pull and remove it. This is your spring-loaded spacer. This is at the bottom of the cartridge. This is the last component of the HSK clamp set. Now with the gripper segments, the clamping cone, and the spring-loaded spacer removed, this is how it'll look in the inside. So to recap, this is the spindle cone. This is the first thing we removed. These are the gripper segments. There's 7 of them. And this is the spring-loaded spacer. Now they're all covered in Metaflux, so what you want to do is you want to take a rag and you just want to wipe everything down. Now you want to be able to see the coating, see if there's any cracks in the material. Just do a good look over and make sure everything looks good. So yeah, I'll clean these. Won't make you guys watch that. The spring-loaded spacer, you want to clean that real well. Go through and clean all the components really well. That's really why you're doing it. You're getting all the debris off. You're just doing a nice cleanse, and you're going to do a re-grease after this. Now that these are all clean, it's very crucial that you check all the wear areas on the gripper segments. All the places that OTT recommends you to lubricate are going to be the wear points. So you just want to check all those wear points and make sure everything looks good. And we'll put a pop-up here. You guys can pause the video of all the lubrication points because that's the next step. So here's the gripper segment. The areas that you're going to be looking for are the areas of wear that are the grease points that OTT recommends. So you're going to be checking here. You're going to be checking this tapered surface, and this surface right here. We'll put a diagram up so you guys can see the exact grease points when we get back to greasing it. So now, let's grease the segment. So you want to take a little bit of Metaflux, not a lot. And you want to do this taper, and this taper, real lightly, and then this taper. This taper will slide against the spindle cone, just like that. The gripper segments are all greased up. Our spring-loaded spacer is clean. Our spindle cone is clean. And here's our patent-pending HSK63A Black Insertion tool. Now, we decided to do a little explanation on the bench before we go into the machine, just so you guys could see it a little bit easier. So here's a spindle cartridge, and here's an M14 thread to mimic the drawbar. So basically what we're gonna do when we go into the machine is we're gonna load the spring-loaded spacer into it and put it to the bottom, just like how it was when we took it out. Also, we want to explain some of the features of this tool. So this is the main, we call this the compression body, and this is the sleeve. So how this tool works is this compression body is threaded, the same thread as the drawbar. So when you thread it in and you turn it in, it'll compress that spring-loaded spacer. Once the spring-loaded spacer is in, we have a flat indicator here and an axis slot here. How that works is when this is inserted, you can take one finger at a time and put it into the spindle cartridge. When you're ready, you pull the sleeve, allowing for the gripper finger to go into the cartridge. You'll see here in just a second. So first, we already have the spindle spacer, spring-loaded spacer in there. Now we're going to thread our insertion tool in. I'm going to grab the flashlight. Way back. We're going to compress it all the way, compressing that spring-loaded spacer all the way. All right, now I can't stop you can't go down anymore. Now this flat, I use this little indicator. All the way down, can't go anymore. Now you're going to turn it counterclockwise and just relieve a little pressure on that spring-loaded spacer. You're going to do about a quarter turn. That's it. Now you're going to use this flat indicator and you're going to line it up perpendicular with one of the crown keys at the bottom. Okay, so you get it as far down as you can. The gripper finger will be just right above that slot that we were just talked about. Now I'm going to pull that sleeve back, and then that finger will fall right into place. And it's really hard to show, but there we go, it popped right in. Now you're just going to keep turning it clockwise or counterclockwise, whatever direction you decide, and you're just going to keep loading these in one by one. Well, there's 2. You're going to keep doing that all the way around until all 7 fingers are in. Then you're going to turn the insertion tool counterclockwise, decompressing the spring, and removing the insertion tool from the cartridge of the spindle. So let's go do it on the machine. We removed all the components of the clamp set. We cleaned everything. Now we're ready to reinsert everything and get it all back together after it's been all greased and get this machine back up and running. So let's put the spring-loaded spacer into the back of the cartridge. Just like that. Now that the spring-loaded spacer is in the bottom of the spindle cartridge, we're going to take our reinsertion tool, thread it onto the drawbar, and compress it. I can feel it compressing. All right, it's fully compressed. Go back just a little bit. Now we're going to line up this flat with this axis slot perpendicular with one of the spuds on the spring-loaded spacer. Okay, and then we're going to push upwards on the gripper finger and pull back on the sleeve. And when we do that, it should pop right in. There we go. So that's number 1. Now we're going to rotate the sleeve and do the same thing. Boom. Now that all the gripper segments are installed into the cartridge of the spindle, you're free to rotate the reinsertion tool counterclockwise and remove it. There's that. So now all you have left to do is insert the spindle cone, screw it in, and set your EM dimension. Here's the spindle cone. Put it in the center. Turn it clockwise. You want to deactivate the drawbar. And turn it. Okay, you don't have to turn it all the way, just turn it most of the way down. Then we'll install our EM calibration tool. And we'll pull back on the dial indicator and we'll just keep checking it. We'll make sure that this dial indicator isn't falling into these balance holes. So this Okuma was set at 417, so we're going to go put it back to 417. We're at 437. Make sure it's not in a hole. 430. 425. 400. So I got to go back now, counterclockwise. 419. We're about 417. And the EM dimension is 10.5 millimeters plus or minus 0.1 millimeters, or 413 plus or minus 4 thousandths of an inch. So now we could take our 5 millimeter Allen, put it through the axis hole, verify that we're keeping that dimension that we want, and tighten it down. Throw the set screw in, 417. Using the live adjustment on the EM calibration tool. Just holding it where we want. Just get it a little bit snug. You don't want to use this as a wrench, you'll ruin the tool. So we're at 416, we're within a thousandth of an inch of where it was. Now we'll remove the hex drive, remove the EM calibration tool. We'll take our wrench flat on our spindle cone and we'll give it a good tightening. Not too tight, as we want to just re-verify. Okay. Now we're going to put the EM calibration tool back on. It's at 415, within a couple thousandths of where it was. Deactivate it. Activate it. 415. 415 again. I would say that's good to go. So now we'll remove the EM calibration tool and we'll grab our torque wrench and we'll use the wrench flats and we'll properly torque this to aught specs. Now we're going to put our wrench flats, we're going to deactivate the drawbar, put the wrench flats on the spindle cone. With our torque wrench at 30 Newton meters from the OTT Jakob's manual, we're going to torque this set screw. Now our HSK63A Black Edition clamp set has been removed, cleaned, inspected, re-greased, and reinstalled into the front of this Okuma horizontal machine center. Now once your EM dimension is set on the face of your spindle, which is from the front of the spindle cone to the front of the spindle, you can take an actual tool and double check and make sure it clamps. Put the tool in, and we want to do a tool clamp. Unclamp. Tool clamp again. It shouldn't have any issues. You've now completed your maintenance on your HSK63A Black Edition clamp set. Now that your clamp set's all back in the spindle and all set to the correct EM dimension, you're ready to run. With the minimal downtime, there's no reason why everybody should be doing this regularly. We'd like to thank you for your time, for watching the video. If you have any questions, feel free to comment or send us an email. We'd love to help. Thank you.